We have these interesting discussions amongst friends, and let's see if anybody else is interested in what we're doing and what we're talking about. So, my first wondering was to you two guys, virtual ECU. What is it to you guys?
Isn't that the solution for everything, right? So everybody's like, hey, virtual ECU will just like replace hills, it will replace hardware, it will do everything immediately and much better, right?
It's the holy grail at the moment, so it solves everything.
So now let's put the sarcasm aside. I think virtual ECU is one of the topics in the industry that is very hot, up and coming, but also has a lot of gray areas where people, including ourselves, need to educate themselves more. So what is that? What are the different levels of virtual ECUs, and why is there no one size fits all, right? So because I think there's a huge misunderstanding out there.
Yeah, and the different levels of virtualization fit better in certain contexts, and then it's as you say. I don't think it fits. One size doesn't fit everything.
Yeah, so I mean, most people or many people don't even know that there are different levels. So you have like a very entry-level simulation, and we did that like many years ago when we just did what we call a rest bus simulation, very German word, right? So that's actually a very, very early stage of low-level simulation for virtual ECU. I just make my computer pretend to be an ECU and answer to CAN messages in a predefined pattern. And then on the other side of the spectrum, I have like the fully modeled everything when I go to the level 4 virtualization, and I have models for each transistor, for each chip, for each resistor, and so on, which makes it very complicated, also very capable, but also very time consuming.
Yeah, and then you end up with as you say, the low level. You get real time. It's easy to set up. It runs fast. But then if you really wanted to model all the hardware, then of course it's the level 4. But then you lose real time. You lose the possibility to connect to other ECUs.
Yeah, and with your experience, Florian, because you've been working at two, let's say, tech-savvy, software-driven OEMs, what was the ideas there, and what was the thinking you had internally before going that path?
So it's interesting. Obviously, my times at those tech-savvy companies a couple of days ago, and we had some ideas, but the technology wasn't out there yet, right? So back what we had was a Simulink and bus simulations. We were thinking about create a whole simulated car at one point, but it turned out that it's getting too complex for what it actually delivers, and it doesn't give you like as Per said, the holy grail, and you have like everything that immediately falls into place. And therefore we actually focused more on like where do we get the biggest bang for the buck, right? And this is what I think also for today the car makers and the suppliers have to keep in mind. Is like, hey, don't just like go level 4 virtualization just because it's the biggest, so must be the best, right? So let's find the best fit for my need.
Yeah, our thinking when we engage with customers is that you maybe it's good to split the functional testing, and then you're good to go with lower level virtualization, and then for the non-functional verification and timing things, then you might just use the hardware. I don't know how that resonates with you, Florian.
So the thing is. I believe we have something we can do today, and we have something that we will be able to do in the future. And to believe that you have a full level 4 simulation today that runs faster than real time is just not realistic. It is also not necessary right now. But we will have improvements a lot. I believe Moore's law applies to virtual ECUs as well, so they will double in capability every cycle, and we will get there for two reasons. Reason one is, as I just mentioned, the capabilities of we're talking, compute resources getting better, cloud computing, AI, and so on and so on. This will all tremendously help. And then the other thing is also, we will actually grow the capabilities and we will add to it. So what do I mean with that? If I look at an ECU today and I have to model every transistor and every resistor and whatever, it's a lot of work. But tomorrow I don't have to model the same resistor again because I already did that, right? And so I build a database and I put all of this stuff there that I can, at one point, I can just like pick all the different components and plug them together, and I get to my level 4 much faster. But to go and believe that you can build a level 4 right now, that's a lot of effort because you have to go through all of those different components to make it work.
And it also, coming back to what you want to use it for, because it might be good for testing one single ECU, but if you want a system-wide, you want the entire car topology running, then today it's even harder to go for the high-level virtualizations.
Yeah, and let me ask you like this: if you want to test the topology of the car, do you really need the exact temperature behavior of the motor control MOSFET?
Yeah.
The answer is no, right? So you don't need that, and that's what I'm saying is like focus on what you want to achieve and find the way of the lowest resistance to achieve that, rather than just to go is like, hey, a higher number must be better, so let's go for a higher number. I wish they would not have used 1, 2, 3, 4, but something different, and this misconception would have been different or gone.
Yeah, but because one misconception might be that yes, if you go for the highest level, then you can scale it down if you need. But it's a completely different technology. It's a completely different approach and setup.
I think this is a very, very important point, and we have to underline that a level 4 is not a tuned up level 3, and a level 3 is not a tuned down level 4. As you say, it's completely different. And you cannot just like make one out of the other by adding or removing something. And I think this is one of the biggest misunderstandings right now.
Yeah. Well, why do you think that there are like different approaches? Well, some manufacturers, they go for, okay, let's keep it simple, level 0 to 2 maybe, while others think, okay, 3 and 4, that's a must for us.
Again, right, it strongly depends what you actually really want to achieve, right? So if your main focus is vehicle level integration based on communication network, then you focus on a level 1 or 2. You're not focusing on level 3 or 4. If you are focusing on like real fine-tuned motor controls behavior in all different environmental situations, a level 1 doesn't help you at all. But it is absolutely different. I mean, it's you're basically like you have situations which are so different, and you're considering similar approaches, right? It's like, hey, if I want to go quick around a racetrack, a motorcycle might be my choice, right? But if I want to bring 50 people to a conference downtown, it's totally the wrong choice. But I cannot just like take a motorcycle and add a couple of wheels to it and then I have a bus, right? So that's in a very picturesque way. How did it not working?
And I also think it also quite a lot depends on where you come from. If you come from the software side, you want fast feedback and fast movement, and then you go for the lower level. If you come from the silicon, then you're used to this having fully deterministic models, and then that's kind of what you're used to. So it's also the background of the people talking about it, I think.
Yeah, I'd want to add what I said earlier is like where we are today and where we will be eventually, right? So I'm talking with suppliers, and they are getting requests now to start to deliver not only actual hardware, but also virtualized hardware or components. And yes, this is going to happen, and this will be fantastic in maybe 5 years, right? So you go to your supplier and you say, hey, I want to have this and this component, and start to work on it. They first deliver you the virtual version, and then they deliver you the hardware samples, whatever, 3 to 6 months later, whatever it is, right? So you can already start working on that. But that's not where we are right now. And at that point, it will be great to have like a much higher integration of virtual components. I'm looking forward to that. It's just not where we are right now.
Yeah. But do you think that the use case today defines what different OEMs are choosing, or is it something else that hinders them or opens up that they're choosing a certain way of doing things when it comes to seal and virtual ECUs?
So it's an interesting question. What is actually their use case? What do they what do they try to achieve? They want to shift left, so they want to test earlier, and then on the other side, they also trying to reduce costs, which is virtual ECUs eventually will be a great tool because you can scale them immediately up, but also immediately down, right? So if I have a peak in efforts, I can just like add some resources and I have more. It's also a misconception. Some people think virtual ECUs will replace actual ECUs. I mean, as long as we drive around actual ECUs in the product, we will actually have to test actual ECUs as well. We will be able to, and I like the word amend, not replace. So we will amend hardware testing. We will not replace it. And it will be great because, yes, you can shift left at one point by using virtual ECUs, and you will be able to add to your hardware testing, but you will not replace it.
Yeah.
And I think that's our thinking as well. It is about running things on hardware that deserves to run on hardware, and then the functional things that you should have ironed out already before. Don't bring them onto the hardware. Fix those before.
At the very least, you will have to validate your simulation, right, on the real hardware. And yes, there are, and that brings me back a little bit to some tests we used, not urgently for virtual ECUs, but we did virtual crash testing, right? And we realized that we can save a lot of money and we can actually be much earlier in all this process. But at the very end, there's still a car that has to go into that obstacle to validate the results. And that being said, so it's an interesting observation. I just had a discussion with a client of mine. The people who are now fighting quote unquote virtual ECUs and protecting their hills, actually the same people who were fighting the hills and protecting the manual testing 20 years ago. That was when I started in the industry, and we had the first hill in the company. And everybody was like, I'm not sure that thing, I'd rather test manually. But in the end, what you see is manual testing hasn't been completely replaced. It had been amended by the hill. And now we're just adding software simulation with virtual ECUs to create a much more complex, bigger picture. But it's not one or the other. It's a complement.
Yeah. And it seems there is like a resistance inside some of these traditional players that, okay, if we go in one way, if we should change it, naturally organization and process-wise, that also takes time. So
there's a saying in German, it's like what the farmer doesn't know, he doesn't eat. And but yeah, no, absolutely. But it is a fact that we see those trends, right? And we see the interest, but we also see it's in a very early stage, and we also see that the understanding is like, it needs to be worked out. And as I say, we're learning as well, right? It's not that as a matter of fact, there's very few people who can say they're experts in virtual ECUs as of today. And so it's very interesting topic. But yeah, to underline what Per said earlier, is like everybody should really think about what I want to achieve and what level is the right one for me, rather than let's go for level 4 because it is the best, because it isn't. It's very targeted for certain use cases.
Yeah, and these days when there's quite a lot of struggle with software, I mean, and taking ownership of software. For me personally, I think it is much about creating this software flow from developer laptops to continuous integration pipelines running virtually, and then in the same pipeline then going over to heel rigs and then building release candidates and moving them to real vehicles, and have this remove the friction in this flow, and then you might need different virtualizations levels.
Yeah, and it's an interesting thing. So the traditional, I just mentioned, I started like a little over 20 years ago, and it was very sequential, right? So you had requirements engineers who write down some stuff, software developers, hardware developers, they do their stuff. Then it came to us, to the integration team, and then they do the validation, and then you have a feedback loop, and you have this cycle which takes like 6-8 weeks, and then you get some bug fixes and then new stuff and so on. And when we talk shift left, that's what we want to change, right? And everybody is pretty much in agreement that we want to change that. And new tools actually support that massively, right? Because to be fair, in 2000, 2005, you had to go sequential or waterfall because this is how just you got the work products, and they were depending on each other.
Yeah. Do you ever think, because we have this like play with words, because traditionally in automotive, you're seeing like the car is naturally, it's the final product, but when they're creating something in the virtual world, they're seeing this as a digital twin, and the digital twin should be more or less like a perfect copy of the hardware. So it means, like, from a mindset perspective, the digital twin comes after the car. But instead of starting in a virtual world, creating your software reference, and at least from software perspective, that's the reference, and then the car becomes the physical twin, naturally, that's needed for the software to run in the final product. Will we ever get there?
I like that approach. I think eventually yes, and I think this is very tempting to think about that, because a car, like a shaped piece of metal, is still hard to modify. We can do, SDVs, and we can do features, and we can all this, but the actual hard shell of the car, it is a station wagon, or it is a bus, right? So I cannot just like change it like that. But if you're moving into virtualization, you can actually do that much earlier. And we see that already in some teams' design, for example. People used to make clay models. I don't know if there's a lot of clay models out there anymore. They all do. And there's a little anecdote, and that's probably like 10 years ago, when I saw Elon with like a 3D glasses, and he was just like walking around in the office like this, because he was just checking out the design of the, I assume, Model 3 at that point. So this is already happening, right? So now we are thinking about the more complex integration and putting feature development and all this integration stuff in there. As an engineer, fantastic, right? I want that, but I also know it's a lot of work to get to that point, and that will take a little bit more time from here on. But yeah, it's going to be great.
Yeah, because it is a little bit strange these days, because in the physical design and engineering, you do a lot of simulation, and then you crash test things, so it feels like you come much further when it comes to the physical engineering, and then when it comes to the software engineering, it's still early days, and you don't really simulate in virtual environments as much.
Yeah, and I think in general, the whole industry has to start to make that brain change, is like developing something from scratch to production. This is still lingering around a lot, right?
Yeah.
So
yes.
When you look from software point of view, we're already starting to make this change, but in general, it's like this continuous everything, right? So that the continuous evolvement has to work its way into the entire product, not only into some parts of it. Which does not mean that you actually have to change, the shape of your car every day, which is also not what the customer wants. The customer actually wants to have some sort of like, cadence of a few years. Because to be honest, if I buy a car today and tomorrow it looks different, I kind of feel bad of that as well, right? But I want to have continuous evolvement. And looking back at the Tesla days, we continuously improve how the technology under the hood worked, right? So and not just every like 4 or 6 years. And this is exactly something that has to make its way in there too. And the simulation can actually have a great contribution to that, because if I have a car with X controllers and I only want to change one of them, and I have already the whole simulation, I only have to plug in the simulated 1% or 5% of change, and then I can play around. And it is highly unlikely that the first shot will work, right? That's why we do A samples, B samples, C samples, because first one. But maybe very soon we can skip those A samples and B samples, and we go into C sample, which is prototype component. And the only thing we have to think about then is the change over to production. So C sample to the 0 series or PPAP, or however you want to call it. And we can skip those very, very expensive A and B samples. At Tesla, actually, we did that already for the Model Y. There was no what they call alpha cars, so no mules anymore, no early stages, because that was run in simulation and on computers. That saves you a gazillion dollars, because those are the expensive parts, right? And then you go and do continuous development on existing product. I mean, you pull a Model S off the line, it costs you $30,000, not 3 million or 30 million, right? And like this, you can do the continuous aspect and skip the A samples in this world.
And maybe skip the super expensive full vehicle hill rigs as well.
Exactly. So there are different ideas and approaches. So I think a full vehicle is great to test user experience. I would not recommend to do a whole everything test on a full vehicle. And that's exactly what costs you not only a large amount of money to build, but also to maintain. And it costs you a large amount of human resources to actually maintain and keep those systems happy. So user experience test on the vehicle, I'm strongly pro, but everything like interaction, integration, and so on, if you can pull that down into a lower level, respectively a simulation, that should be the goal.
Definitely.
So what's the kind of conclusion of all of this? To use it seems like we are strong believers on simulation, virtualization, and then that we need different levels of ECUs virtualization depending on what you want to achieve. If you're going to go for system wide, then maybe go for the lower one. If you want to go for engine control and a single ECU, then you might go for the level 3 or level 4.
Yeah. So my conclusion is exactly what you say. So first is define what you want to achieve. Second is use the right tool for the job. The third is the great news. The future is bright. There is more tools than we used to have, and those tools are actually helping us a lot. We have to understand how to use them, how to plug them in. And then the last part is, yes, we will have super complex full simulation in cars at one point. Off cars, not in cars, off cars at one point. But for today, let's use what we have available to actually gain a benefit. And if you have a research team that works on the other option, but let's gain advantage of everything we have right now, and use it to the right case, in the right case.
Yes, that sounds good. And also to reuse things continuously and see as you mentioned, what's the use case, and maybe put a more holistic view. Else you might, from your team, okay, I'm looking at my silo, and then Per and his team is looking at his silo, but then you don't get a consistency from an integration testing perspective for the full vehicle, since it's built up with components and that you add together, start to talk together, and then you have the vehicle at the end.
This is a fantastic point. Communication is still the number one thing that can be improved in any automotive company. And we've seen so much redundant work done by people solving their own issues without talking about other teams that might have the same issues or solutions already to the issue, right? And this is something just as a throwback, what we did implement at Tesla. We had a regular meeting every Friday for an hour where all test engineers of the company were invited, all software test engineers. And just to showcase what is your problem right now, what are your problems, and what are your solutions, what are you working on? And we found out there was such a redundancy, and we just bundle that up and say, okay, cool. So you solve that problem, that gives me time to solve that problem, and in the end, we all gain a benefit out of it. So yes, communication still number one improvement topic in any company.
Yeah, man. Well, once in a while we use a quote from you, Florian. That is something you say something along the lines. Writing code is not the problem in the industry. It is integration, and then of course integration and communication. It's kind of in the same bucket a little bit at least.
Yes, absolutely. I think that's a good closing argument. I just had click away the bad internet connection. It's not bad. It's fine. Okay. Yeah, no, I think that's a great conclusion. And we are happy to learn more and to discuss more. I'm sure with everybody who's out there working on the topic. It's really a new topic, right? And there's progress every day, but we also have to understand that progress takes some time, and we should not. I mean, yes, shoot for the stars, but aim for the moon. Not the other way around. Aim for the moon and shoot for the stars.
Good, and let's collaborate and make some nice stuff out of this.
Absolutely.